At the end of the last recording, I talked about a common pattern where you want to use a loop, where you want to be able to access both the objects that you're iterating through and the index of those objects or those items within the thing that you're iterating through. And I introduced enumerate as a concise way of doing that. But what I did forget to do was just show you this example again using enumerate. Before we go on, I just wanted to do that. So here it is, the same thing that we had before, but instead of keeping our own separate count or our own index outside of that loop and updating it within the loop, here we just use enumerate, get out a pair containing the index and the line, and then we can use both of those within the loop. Okay, I wanted to go back to our C levels again and do some more data cleaning. So we were looking at, remember that we got this information in from our Fremantle C level recording site, and we had these 4 columns of data. So one representing the date, one representing the mean C levels, one representing the number of missing days of recordings within that month, and the flag at the end here. So we looked at the flags and we saw that there were no cases where the flags showed that we couldn't trust the data. The next thing I wanted to look at was, you'll recall that they used a special number -99999 within the mean C levels to indicate a missing month or incorrect month from that data. So we want to deal with them next. So let's go back to our mean C level data and have a look at the missing months. And you'll recall that the missing months were indicated by a mean C level value of -99999. So we're interested to know whether any of those exist within our data. We saw that some do from eyeballing it before, but let's say it's a very large file. There might be millions of items in that file. We want to know whether any of those exist. So let's just start by having a look at mean C levels. Okay, so we can print some of those out or evaluate some of those and see if there's any there, but that doesn't tell us, of course, whether there's any in the entire file. Remember that we looked before at element-wise operators over arrays, so we can check to see whether the entire array is equal to some value all at once. So let's try something like missing mean C levels is equal to our mean C levels is equal to -99999. Okay, we don't actually require these parentheses because this operation will take precedence over that operation, but it actually reads a little bit better. It reads a bit better if we do. It's a bit clearer. And remember that we can then use our any function. So in this case, we're using the any function that's a method of that array, as opposed to a built-in one. And we see that it's true. Okay, there are some missing C levels where the the sea level value is minus 99999. So what we want to do is we want to remove those months, and we could do that by going through with a loop. Each time we check whether the sea level is equal to minus 99999, and if so, we exclude it from our accumulator. But there's a better way of doing it, and that's called masking, and that's something that we'll use quite a lot. So I thought I'd talk a little bit about that. So arrays can be indexed using integers, the same way as lists. We've seen that before. Using slices, we've seen that before. But they can also be indexed by other arrays, and in particular by Boolean arrays. And if we use as our selector for the array a Boolean array, it will return each element of that array where the Boolean value is true. And that can be very useful. And that array of Booleans, we sometimes refer to that as a mask. It's not an official term, but it's a common term to use. That mask must be the same size as the initial array. So if we have a look again at our here we worked out missing MSLs, so let's just check what type of array that is. We could have used type as well, but let's just have a look, and we can see it's an array of Booleans. The first 10 of those, of course, are false. If we look at 20, we'll get a true value in there. Note that we can't just use this to look through the entire array because it may be very large, and so what the notebook does is it just prints a few at the beginning and a few at the end to give you an idea, but we don't know how many in there are true. So we've said that we can use this missing MSLs, this Boolean array, as a mask to get out the items of the missing C levels. So let's just check firstly that both of these, we said they had to be the same size. So if we print the length of MSLs and the length of missing MSLs, then we'll see that those are different sizes, which means that we've done something wrong. So this is an example of why it's always good to print things as you go to check your work. And I've used the wrong MSLs value, and the notebook has used one has used that value because it's already in the memory. Okay, so the two are the same length as expected. So what we want to do now is do the actual masking. So if we say we take our array of MSLs and we mask that with our missing MSLs, okay, so you can see that it's created a new array where it's selected out. So this is selection, just like we've done with slices before, but now it's used that Boolean array as a selector to get those items out. And we might want to just see what how many of those there are. So we can just look at the the length of those. Seems to be going a little bit slow today, and we can see that there are 109 of those missing values. So that's an example of masking, where we sort of, you can think of the array of booleans as being a bit like a I don't know, say a punch card, where you have holes for the true values and no holes for the false values. And so if you look through the holes, you see all the true values. So that's what that's kind of where that word masking comes from. You know, it's kind of like a mask where you can only see through the ones that are true, but the ones that are false are masked from you. So that's how we get out the ones that are the missing months. Actually, we want to keep the ones that are not missing. And we can do that using another one of NumPy's element-wise operations, in this case the logical operations. So let's have a look at those. So again, this is our NumPy documentation, the logical functions, and you can see there's a whole lot of useful things there for testing. We've already used or we just used any, in fact, this one here. You can check whether they're all true. You can check some things about arrays and comparison between arrays and so forth. The one that we're interested in this case is this one here, logical not. So what that does is it goes through and it takes the logical negation of each of the elements of the array, as opposed to not that we've used previously, where we've just had one true or false value. Okay, so well, I've got that here. So remember, Python logical operators and, or not. So we can say if something and something, then we go and do something. That's a logical operator as well. It's a conjunction or an and in that case, but it's not an element-wise operation. It's just on a single truth value. So we can say something like a MSLs, and now we want to get out not the ones where there are missing values, but the ones where there are not. So we can use numpy.logical not missing MSLs. Okay, so that gets out a much larger array with all of the values that are not missing. So that's one way to do it, which is fine. There's another way to do it. How can we do it without using logical not? Well, of course, you've probably worked it out up here. So we've said our Boolean condition there is the mean sea level is equal to minus 99999. All we need to do is say is the mean sea level is not equal to minus 9999, and that mask will get out all the ones that are not minus 999. So there's more than one way to do it. So let's just summarize where we're up to so far. So now we're going to drop, we used list of for the list and a for the arrays, just to clearly distinguish the two. We wouldn't normally bother to do that. Like all Python variables, we get the type from the context. And so we'll drop those. We won't need that fourth column, the flags, so we'll drop those from now on. And for simplicity, we'll use the just the other masking method where we've said we want to get all those that are not equal to that value. So that's our new mask, and we're just going to mask the dates, the mean sea levels and the missing days. Remember, we've got to mask all of them because those things need to coincide. Okay, so next we've looked at the missing months, and next we'll go on to look at the missing days.